What is Coulomb's law? Coulomb's law is saying that there is an electrical force, or the force acting between two charged objects, very similar to gravity or gravitational force, because both of them are non-contact forces. This electric force between 2 point charges, Q1 and Q2, is given by Coulomb's law using this formula. Fe, which is the electrical force in terms of Newton, equals to K times Q1 times Q2 divided by R squared. What is K? K is called Coulomb's constant, and the value of K is 8.99 times 10 to the power of 9 Newton times meter square per Coulomb square. That is constant and is not changing at all. What is Q1 and Q2? Q1 and Q2 are the charges of the two different points. So, and R is the distance between Q1 and Q2. The force between 2 point charges is inversely proportional to the square of the distance, as you see here is R squared, between the charges, and directly proportional to the product of the charges. R, distance between the charges, must be in terms of meters, and these charges must be in terms of Coulomb. For example, if you have microcoulomb, you need to have it multiplied by 10 to the power of -6 when you convert it to Coulomb. And since it's a force, we are dealing with a vector, and the direction of the electrical force on each of the charges is along the line that connects the two charges. How do we figure out the direction? We know two like charges repel each other and two unlike charges attract each other. So based on this law, we can figure out what is going to be the direction and magnitude of the electrical force. Let's go back to the formula one more time. As you see here, if a charge becomes double, force becomes double. If R becomes double, force is going to be divided by 4. It's going to be 1/4. Why? Because 2 to the power of 2 is going to be 4. So when R is increasing, when the distance between charges is increasing, force is decreasing. If the charge of any of them or both of these points are increasing, the force between these two charges increase as well.